Alright, time for another DraftPhysics.com video presentation. So, some more relativity crap connected to kinetic energy crap. And so there's been some comments on uh, physicist Michael's video. Yeah. Sorry, just laughing at the the critique of a spelling error. What a waste of time. Talking to some people. But anyway, so I've already been over this and over this, but I mean, it just seems to me that there hasn't been any explanation. So here's the same crap I had on the board before. Now let's just say there is no other ship. Who cares? Let's just get rid of him watching this happen. And you're just sitting in your own spaceship, okay? And you have you have a, a gas meter, you have an indicator that tells you how much fuel you're using, not how much you have left, just how much you're using. It doesn't really matter. But, just the idea of a gauge, okay? And, it swings back and forth, I guess. Put an arrows in there or something, I don't know. Anyway, and so you know how much fuel you're using per unit of velocity. Okay, and you can measure your distance. Let's see. Well, you don't need to, because you can measure your velocity. You can measure your acceleration. So, how do you get past this fact that this kinetic energy thing just doesn't work? Okay, I mean, this is 3 times the fuel here, 5 times the fuel here, 7 times the fuel here, 9 times. It just keeps going up and up and up and up and up. Numbers get extraordinary for attempting to go any real fast speeds. You're talking about hundreds of times the fuel to go 100 miles an hour. I mean, it comes out to, let's see, I could figure that out, right? So 25 miles an hour would be, that's when you get into 25, right? 5 times 5, right? It's 5 times 5, right? 4 times 4, 5 times 5, 25. It just gets crazy. The numbers get worse and worse and worse and worse. Anyway, so you can see it in your own ship. You're sitting here watching your fuel consumption, so of course you can tell how fast you're going. Because if you're going from 5 miles to 10, you'll use, 3 times the fuel. And when you're going from 10 to 15, you'll use 5 times the fuel. And when you're going 15 to 20, you use 7 times the fuel. So, I mean, that'll be an indicator of how fast you're going. It'll tell you how fast you were going, because you'll see how much fuel you have to use to go faster. So it tells you what it's doing an experiment where the physics aren't going to be the same. No matter what speed you're going, this physics is going to be different for each speed. So how do you overcome even that? Let alone the idea that all these different observers from different locations doing different things are somehow going to be able to see you use different amounts of fuel. I mean, the fact is, I was sort of saying that, no, let's just say the fuel gauge is right on the ship. It's got to use one kind of fuel. And what physicist Michael was basically saying is, well, just figure out the maximum observer, and then we'll just say that whatever the maximum amount was, that's what he used in all from all frames. Well, that doesn't make any sense. So there really has to be. Like I'm just saying, you can't really play this relativity game, in terms of no absolute space or velocity, because it doesn't work. I mean, you can't have a non-absolute space and then have real circumstantial numbers that change depending on how fast you're going. What speed you're going from to. If you're going from 10 to 20, it's a different number than if you're going from 40 to 50. Okay, and if any 10-mile increase, any 50-mile increase, it always matters from which one you're changing. So at every current speed, every 1 mile an hour you add to any speed you already have, 200, 250, 2000, whatever you add, it's a specific amount of extra fuel that you have to use to go that extra mile an hour. Every mile an hour costs you a different amount of fuel depending on what your previous condition is. So, this mush they're talking is just so unresponsive. So I'll read the comments in this context. This is the problem I'm saying. How does it work not being able to just read your own fuel gauge and see how much fuel you're using for the acceleration? That is, you can watch something move in your spaceship. When you accelerate, you can just watch it move and say, that's how much I accelerated. And you know that you have to pay for that based on how much, based on what your previous condition was. And depending on what your previous condition is, you're going to pay more for that bit of acceleration. You'll pay a different price in fuel. So you can just read it right on the gauge and it'll tell you exactly how fast you were going and how fast you are going. Doesn't that break relativity? Yeah, so they're going to play math games, so they're not going to be able to draw it. They're certainly not going to be able to show any physical experiments demonstrating that somehow it doesn't matter, that it takes a different amount of fuel to go faster depending on what speed you're going, and somehow that isn't real. And so they're playing word games with chemical energy and using different names. I mean, I did make it clear in the 2 videos I made that you could use photons. You could use something that's going almost this, 300 million, 300 million meters per second. Hugely fast compared to 10 miles an hour. So it couldn't possibly make any difference to the relative speed of your fuel versus your speed because it's infinitesimal difference. So you can't play some game that relative to the speed of your fuel that somehow you're gaining on your fuel. And photons are supposed to be going the same speed in all frames, so it shouldn't matter anyway. It should all be perceived as 300 million meters per second, no matter how fast I'm already going. So they're just, I'm just going to call it games they're playing. This is not real. All right, so I posted my response video, and White Henry, whoever the fuck or whatever the fuck that is, did you post the wrong link? ? You addressed nothing of what Michael did in the video. Yeah, I didn't address any of that mathematical crap. I don't believe any of that is rational. I don't believe it has anything to do with reality. I don't think anything works that way. I don't believe you can say the fuel used up more of the energy or some other nonsense. I mean, the only way you can move is because of the momentum exchange, frankly. Newton is right, and that's how thrust works in space. So you can pretend that somewhere NASA has verified that thrust in space works based on kinetic energy theory, but it doesn't. So, you're going to have a hard sell making that sell that NASA doesn't know that you can, you use the fire extinguisher and you can move in space by just shooting momentum, and that's all that takes place. And there is no kinetic energy theory. There's no, it takes twice as much fire extinguisher. It takes 4 times as much fire extinguisher to go twice as fast. NASA doesn't believe that. So just keep playing whatever this bullshit game is, right? There's nothing I can say to this. I don't know what this stupid Watto said here. It's just stupid. Thanks for the video. My only comment would be that the brief foray into specific impulse, earth, and gravity was unfortunate. So I guess he's saying his previous explanation was blah blah. I almost lost interest and attention during the irrelevant segment. So whatever. Who cares what interests you? You stupid fucking mindless troll. Anyway, so White Henry again. Which one should I read first? Oh, I might as well do this one first. There's a slight inaccuracy at 3310. You said that all observers will agree on what the change in KE is. It would be more accurate to say all but one observer will agree. So this is his, he's trying to be humorous, right? It's sarcasm directed at me, I think. And so he's not really making a point. So I love these people that have to, they have to do something sarcastic and they don't say before the comment, this is sarcasm. Because frankly, most of them do the sarcasm so poorly that you don't even know it's sarcasm. People's jokes are so bad you don't know they're jokes. So both of these So Mindless Marbles and Physicist Michael both fall for it. Can you clarify? My understanding is that all inertial observers will agree on the change in total KE of the rocket. So obviously the person who's actually accelerating isn't inertial anymore, but what's the point of arguing this crap? The total KE of rocket and exhaust. Again, the total KE is irrelevant. Every explosion, the energy goes in both directions. In every explosion, if you're going to capitalize on the explosion to go one way, the only way you can do that is to contain the explosion in a vessel and then have the exhaust go one way. But that's difficult to do, So you're always stuck with a huge exhaust problem. I mean, the exhaust is, all that shit coming out of the back of the rocket is essentially waste. I mean, that's all good heat energy that you're losing. Can you explain why you disagree? So, since the velocity term v, which is included in any information about the relative motion, so again, the velocity term v, whatever that means, it's not a defined velocity. So what's the point? You're not ever saying what the velocity is. You're just saying whether you're increasing it or decreasing it, but you never assign a value to it. And that's the only way you can escape this reality that the amount of fuel changes depending on what the initial V is. All right. Canceled out, and should be all observers agree on the total change in KE for the system. So the point is if you assign a real value to that V, which you must do, frankly. I mean, KE requires you to do it, because you can't figure out how much fuel you're going to use unless you know how fast you're already going. Which observer are you referring to? So I think he was referring to me. But whatever, who knows? Maybe I saw a joke where one wasn't. Alright, then White Henry again. At 4727, you are basically saying it takes twice the fuel to go twice the speed. So I don't know where he said that, but no, he's not. DS always thinks that physics' position is that it takes 4 times the fuel to go twice the speed. Yeah, and it takes 9 times the fuel to go 3 times the speed, and it takes 16 times the fuel to go 4 times the speed. That's what they say. That's what they believe. So again, why are this is just, it's almost, I mean, this late in the game to have to even argue this kind of crap over and over again. They're saying twice the spring compression is 4 times the energy. They're overtly saying that's what they believe. All right, due to the mv squared ke formula. Where's the contradiction? I don't even know who's contradicting who. He's saying there's twice the fuel to go twice the speed. Obviously, he's not saying that. You can't say it, okay? There's no way you can possibly say it with a straight face. If you believe Leibniz was right, then you have to pay the price for Leibniz being right. That means you have to recognize that with every increase in your velocity, it takes more fuel to go faster. More fuel than it did at the slower velocity. I mean, I can show Professor Lewin basically pointing this out, that this is screwy. Okay, where's the contradiction? As I understand it, each equal increase in velocity takes the same amount of fuel. So we know that's not true. So we know if we assign an actual value to this guy's speed, it can't possibly be the same amount of fuel. We know if we actually have a spaceship in space, it's going to use a specific amount of fuel. It's just idiotic to say it isn't, okay? We've already done this. They've already moved things in space with thrusters. They do it all the time. They know exactly how much fuel it costs to do a certain maneuver. So this has all been done already. And if you're saying that if this kinetic energy theory is true, the only thing you have to concede is that it doesn't work. That it doesn't have anything to do with thrust. That thrust is momentum, and that's all it is. So just concede that kinetic energy the kinetic energy theory doesn't apply to any engine that operates on thrust. That operates on the principle of throwing away something. and to go in the opposite direction. But don't, this is just such bullshit. As I understand it, each equal increase in velocity takes the same amount of fuel. And it's like, well, there's no argument then. And you're basically conceding there's no kinetic energy then, right? I mean, again, you either take account for what you believe or you don't take account for it, and you just come up with some silly, well, there's only kinetic energy when I say there is. But the rocket gains KE quadratically. How does it do that? How does it convert 2 units of fuel into 4 units of energy? Because that's free energy then. I mean, this is just, I can't believe this is such a regression in the argument. While the exhaust material loses KE quadratically. So again, how does it do that? Where does it lose it to? Magic? You can't lose energy, right? Energy always ends up as heat somewhere. It can't get lost. It can only get smaller and smaller. It gets broken into smaller and smaller pieces, but it's still going somewhere. It's always on the move. The 2 quadratic elements cancel out, whatever that even means. How and who canceled it out? Who paid for the gas? How do you cancel out gasoline? Anyway, leaving a constant difference, i.e. a gain in KE of the whole system per unit velocity increase. So again, it's a fuel tank. You can read how much you're using. You're saying kinetic energy doesn't apply to rockets. That's all you're saying. So go ahead and say it plainly instead of keep evading saying it plainly. That, oh yeah, this theory that's supposed to be elemental really isn't. Doesn't have anything to do with most things. It only has to do with when we want to apply it. This is just so... So I just point out, okay, as I understand it, each equal increase in velocity takes the same amount of fuel. And I put in my response, if that is what they believed, then there wouldn't be an argument. So clearly, if that's the truth, okay, that going from 30 to 40 is the same amount of fuel as going from 10 to 20, if they believe that, then there's no argument, because then, right, it doesn't matter what speed I'm going, a 10 mile an hour increase is going to look like exactly the same. I'm going to use exactly the same fuel to go 10 miles faster. But that's not what the kinetic energy formula says. Alright, now Mindless says, there's the mass being ejected, and then there is the chemical energy being used to eject the mass. So this is more game playing. Obviously, it's just a force in the end. So whether you say the photons push little atoms out the door, or whether you shoot the photons themselves out the door, doesn't make any frickin' difference. Those two aren't the same. Yeah, they really are. The force and the momentum of an object that you gave the force to. That is, you use a force, you apply it to an object, you give the object momentum. As Newton stated, it's still the force, essentially. The force is now just in the object you gave momentum to. It has an equal capacity to give the force back, to cause something else to move with the same amount of force. Newton's cradle. Come on. But yes, as far as I can tell, when it comes to delta KE, so the change in your kinetic energy, the increase in total KE, which comes from the chemical energy, is invariant under change in reference frames. So if it's invariant, then it's not kinetic energy. Then it's momentum. So I don't know, you people are just so two-faced. Note that in the car on Earth example, it matters how fast the car is moving relative to the Earth. Why does that matter? I mean, it really doesn't matter. The fact that you've put the energy, whether you spin the wheels and you go, or you spin them and push on an earth and go. Again, people have made this argument about exhaust before. Oh, well, how could your engine, your hydrogen engine work if it's not pushing against something. They think the exhaust needs to hit the ground, or it needs to hit air, or it needs to hit something, or you can't move. It has nothing to do with it. So then you should have a quadratic increase, v squared, in the needed energy to go from 0 to v. So 0 to v, right, or 10 to 20 versus 30 to 40 versus 40 to 50 is all a different amount of fuel according to the kinetic energy theory. You can't deny that. If I had a spaceship and I'm sitting in it and I read your stupid physics books, I would know that's what I'm going to do. I'm going to have to pay for it. But we also already know that NASA's already done these experiments and KE doesn't show up anywhere. So in a way, I shouldn't have to even argue any of this crap, because one of the most fundamental, elemental ways of moving through space, KE doesn't work. It doesn't apply. It doesn't take twice the energy to go twice as fast when you're in space. So isn't that a glaring example of how your theory fails to describe reality? Oh, shit. Alright, so we have 2 comments by PhysicistMichael. Stupid name, by the way. I mean, I'm just pointing out because of this. He said in one of the comments, you might want to double check your spelling of relativity in the video title. I checked nothing. Okay, I couldn't give a shit if I spell something wrong, especially if it looks close enough. So it looks something like the right word, I'm going with it. I just couldn't care less. You know, man, you people are just such pieces of shit. I mean, come on. Anyway, a more precise way of describing it would be it takes 4 times the... I mean, sometimes my hair isn't combed. Did you notice that? How outrageous. Did you know your hair isn't combed? A more precise way of describing it would be it takes 4 times the energy for a single object to go twice as fast in a particular reference frame. So he's saying it takes 4 times the energy, but it really doesn't. All right, so I'm just saying, we know that in space it doesn't do any of this stuff, right? So we know that thrusters on spaceships do not obey the kinetic energy formula. I mean, NASA doesn't say it overtly, but it's in all kinds, they've signaled this truth in all kinds of ways, when they talk about Newtonian physics. But whatever. I mean, so we need a NASA scientist now to answer the simple question. Oh, it's just so pathetic. Anyway, in both a chemical rocket and a driving car, that energy is provided by a release of chemical energy in the fuel. Who cares what the source is? I mean, you're just playing games again. It doesn't have anything to do with the source of the fuel. The point is your theory says if you want to go twice as fast, you have to put in 4 times the energy. You can't do it with twice the energy. You have to put 4 in. And if you want to go 3 times as fast, you have to use 9 units of energy. So because you keep thinking that gravity is a per foot force, when clearly it's not a per foot force, it's a time dependent force. So because you can't understand something that simple, 9.8 meters per 1 second, everything else is broken. But it's just clearly broken. Anyway, for the car, starting at a rest frame of the car, thank you. Essentially, all the released chemical energy is going into KE of the car, almost nothing to the recoiling Earth. So the recoiling Earth is almost irrelevant anyway. It is irrelevant, but it doesn't really recoil. So again, this is all part of their understanding of reality, is that every time something reflects off an object, they think twice as much energy went into the object, when no, the whole reason why it reflected is because none of the energy stayed in the other object. All of it went in and came back again. That's the only way something can bounce with 100% of the momentum still possessing 100%. The only way it can bounce back possessing 100% is that something had to steal nothing. And like, you know this again from space arguments. When you slingshot using a planet's orbital speed, there's circumstances where you can slingshot and you don't take any of its orbital speed. You just go into the gravity well and out with the same speed. But if you actually do increase your speed, then you have to steal some of its orbital speed. So we already know there's a 2-to-1 relationship, even in that circumstance. Well, we understand, we know. I know. Okay, I know it. Whether the rest of you will catch up someday, who knows? Anyways, it's just so bad. All right, almost nothing going to there. So we need that full 4x fuel consumption for the car. So again, so he's conceding it's 4 times to go twice as fast. But more importantly, okay, is that every increase has a different amount or a value difference. So every mile will cost you more depending on your previous velocity. Every mile per hour. Okay, for the rocket, starting from the rest frame of the rocket, the vast majority of the energy is going into the motion of the exhaust. So that makes no sense at all. I mean, he's just mocking Newton's third law. Clearly, there's this equal and opposite thing that you're taking advantage of. And the big giant flame coming out of the rocket is an indication of an opposite flame that's going into your rocket, making it move. The forces are balanced, and you're getting as much as you're giving, as you're letting go. Only a tiny fraction of that energy is going into the rocket. Says they just make this stuff up, frankly. They got no reason to believe a tiny fraction of something. No, nonsense. So this is like the bullet and the gun argument. He's arguing that a big pile of joules of energy goes into the bullet. 2,000 joules goes into the bullet, and only 2 joules goes into the recoiling gun. And he actually thinks that's how it works. Okay, so even though the momentums are the same, the amount of kinetic energy because of the squared term is insanely high for the bullet. But the fact is I think you can make the argument that if I could crash the recoiling gun into the bullet's not going to win. It's really not, okay? I mean, the 1,000 atoms going 1 mile an hour are just as powerful as the 1 atom going 1,000 miles an hour. And as the rocket velocity increases, as you said, the greater proportion gradually shifts towards the rocket. So whatever that even means. The higher your speed, the more energy you have to use. You can't throw it away. Anyway, I don't know. So of the 2x fuel ejected, again, most goes to the exhaust, but for that second fuel use, a greater proportion of that energy went to the rocket. Says this is all just, they're just making up proportions of the energy. And so they're basically saying that we'll just pretend the energy was in 2 directions, and I can pretend one direction has 9,000 joules and the other direction has 9. And I can just change those numbers anytime I like, even though they're identical momentum numbers. Overall, adding up the 4x energy going into the rocket. So again, he's saying the rocket's going to use 4 times the fuel, but it's not connected to any actual velocity, so there's no way to see whether it's 4 times or 8 times or 16 times. But anyway, the kinetic energy equation still shows up, but the transfer is more complicated. It's just convoluted. It's not complicated. It's contrived convolutions. Another key point is that conservation of energy still absolutely shows up in determining what the effective exhaust velocity U will be. And so you wrote that wrong. Should I point that out? Shows up in determining what the effective exhaust velocity U will be. You should have a comma there. Yeah, before the U, after the U. U should be like hyphenated or something. And this is the most apparent for things like ion engines. So whatever the fuck one of those is, I mean, they do have solid state thrusters, but I don't think they have anything called an ion engine. Okay, I don't think NASA's built one yet, but whatever. To me, it's more obvious how the faster you get to the speed of light of your fuel, the more the whole thing becomes moot, because you need a tiny bit of mass to create a huge amount of, total momentum. it's more efficient, I guess. It takes far more electrical energy to launch particles with higher U value. Says you again, it takes just the amount it takes. It's heat. Electricity converts into heat quite efficiently, frankly. DS doesn't seem to think the kinetic energy formula shows up anywhere. I don't even understand how you could say that. I'm saying it's right in your face, and the formula is basically mandating, okay, that there is variance depending on what your initial speed is. Whatever your inertial speed is going to change how much fuel you have to use to go faster. And that will be apparent to not only you looking right at your fuel meter, but it'll be apparent to any observers anywhere that they could see your fuel meter also. And so you're just playing a game pretending there's no real speeds. Alright, so that's all there is, I guess. Maybe I'll refresh it just to see if there's anything new. But just too stupid. I mean, the subject's just being avoided, as usual. I mean, the subject is that if you're going to have this kinetic energy theory, then you have to show that it is elemental and universal. And I'm just saying, it clearly creates a signature, something you can see, a footprint, a fingerprint, that leaves a mark. And it leaves a mark in all of these relativity conversations because now there's a giveaway. The amount of fuel matters. If you can see the fuel, you can see the speed. You can know the speed. Alright, so enough fun. It's just disappointing. Whew. And we're still waiting on the lever experiment. The results, some kind of indication of initial progress. You know, is it working? Is it not working? How much does the lever? How much energy is lost? You know, to the lever, however you constructed one. Like I said, I started having my doubts when I started even just thinking about the big heavy gear thing he was using, the ball bearings, because, you know, should keep it light and simple. A stick with a hole in it, you know, on just an oily surface, just so it can spin. That's all you need. But anyway, till the next time and such, I guess that's all I have. Too bad the initial guy who started this with a question, he hasn't shown up. But I don't think he's totally satisfied with this explanation either. It's just a bunch of mathematical evasions. Anyway, till the next time and such and so forth and whatnot. Yeah, it really is enough.